Okay, so energy is transferred from the thermal store of the water to the thermal store of the air with an efficiency of 16%. So that means that energy is flowing from the hot water to the cooler air. It's flowing from hot to cold. The air in the boiling tube gains that much energy during the process, and this is useful energy transfer. And then we've got the efficiency here, and it's asking us to calculate the wasted energy. So the formula for efficiency is that it's the useful energy out over the total energy in times by 100 to get it into a percentage. So if we just substitute what we know into that, then the efficiency is going to be 16%. Okay, and that's going to be the useful energy out, which is 1,800, divided by the total energy in, times by 100. Okay, so to what we're going to do is we're going to multiply both sides by the total energy in, and we're going to divide both sides by 16. So what's that going to look like? Total energy in ends up on the left on its own, and then we've got 1,800 times by 100, okay, divided by 16. Right, if you tap all of that into a calculator, allow me to tap it into a calculator, then you're going to get that's going to get you 11,250 joules. Okay, so is that our answer? No, we've worked out the total energy in. So now we've got to think about the principle of conservation of energy. Okay, so that the total energy inputs are going to be equal to the total energy outputs. That's just the principle of conservation of energy, right? And then what have we got? We've got the useful energy output, which is 1,800 joules, and then anything else must be the wasted energy out. And then we can calculate that quite easily. We're just going to subtract 1,800 from both sides, and that's going to get us 9,450 joules. But if you've been listening to me, you'll know that we've got to look back. Two significant figures, input data there. You could argue that that's 2 or 4, but we always go with the least number of significant figures of the input data. So really, we should be giving our answer to 2 significant figures, and the best answer is 9,500 joules. 2 ways that the apparatus could be modified to improve the efficiency of the energy transfer. Okay, so we've got to go back and really look at that diagram to think this through there. Okay, what we're actually seeing is heat flow from the hot water to the cold air, and what we're talking about is trying to make that flow of heat easier. Okay, so one way that we could do that is we could use a boiling tube, that potentially it's got thinner glass walls, because if it's got thinner glass walls, then the heat will conduct more easily through. Or you could use a boiling tube that was made out of something that was a better conductor. So instead of being made out of glass, potentially you could use something like a metal boiling tube. The other thing that you can see here is, not all of the boiling tube is covered. So if you used a deeper beaker like that and increase the level of the water in the beaker, okay, then you'd be getting heat flow in through this area as well, and that would heat up the water in the boiling tube faster. Okay, so all of those are good ideas. The other thing to think through here is it's the temperature difference that's driving this. Okay, so when this is very hot and this is cold, then the flow of heat is going to be much larger. So the other way of thinking about this is, okay, what can you do to keep this as hot as possible? And there's a couple of ideas that you could have. You could put a lid on the top of the beaker to stop heat being taken away from the water by convection currents. Okay, that would work. You could wrap your beaker in a big thick layer of insulating foam, any good insulator, and then finally, this one's an interesting one. You could wrap it in a silver layer. Now, why do we want to wrap it in a silver layer? Well, the idea is that this beaker at the moment is radiating heat away from itself. So if you wrap it in a silver layer, you'll remember silver is a good reflector, which means it's a poor absorber, which means it's a very poor radiator. Okay, so wrapping your beaker in silvering aluminium foil, any kind of shiny outer layer to the beaker would do that. Okay, that's the end of that question and the end of the standard portion of the paper.